Hello everyone, I am Sheetal Nagar from BTech EC Department, IIMT Group of College Greater Noida. Today my topic is Intel 8085 microprocessor addressing modes. What is first of all, what is 8085? 8085 is a microprocessor which is introduced by Intel company. 8085 is a 8-bit microprocessor which microprocessor have 16-bit address bus. Now, today we will discuss addressing modes of 8085 microprocessor. Now, so first of all, what is addressing modes of 8085 microprocessor? Uh, Basically, the way of specifying data to be operated by an instruction is called addressing modes. Means every instruction of 8085 microprocessor contains two parts, opcode and operand. Opcode is nothing but this is the hexadecimal representation of any operation which is going to be performed by 8085 microprocessor, which is previously defined and designed by Intel company already. Or we are studying only instruction which is already defined by the Intel 8085 microprocessor. Okay. Now, to perform any operation, we use instructions, and these instructions specify within three things: operation to be performed, address of source of data, address of destination of result. Means all instructions have some registers, some data, and some instructions contain nothing in front of them. Okay. Now, if we talk about the 8085 microprocessor instruction set, the whole instruction set of 8085 microprocessor is divided into five parts. First one is first one is uh, okay, like arithmetic group, and the next one is our logical group, branch group, machine control group, and first one जो कि most important है, that one is data transfer group. Means every group contains some instructions which have some addressing modes. In 8085 microprocessor, the method by which the address of source of data or the address of destination of result is given in the instruction is called addressing mode. The term addressing modes refer to the way in which the operand of instruction is specified. In 8085 microprocessor, we have five types of addressing modes. Now, first one is direct addressing mode. Second one is register addressing mode. Third one is register indirect addressing mode. And fourth one is immediate addressing mode. And last one, implicit addressing mode. These all are the addressing modes of 8085 microprocessor. Now, first one, direct addressing mode. In this mode, the address of the operand is given in the instruction itself. For example, we can take any example for to explain the direct addressing mode. For example, in this case, we have taken LDA 2500H. In this instruction, first of all, LDA is the opcode for this instruction, and 2500 is the operand for this instruction. In direct addressing mode, the data to be operated is available inside a memory location, and that memory location is specified as an operand. Means 2500 is operand in this instruction and LDA is opcode. Now, what will be the output of this instruction? That is LDA. What is the full form of LDA? Load accumulator directly with the contents of memory location, that is 2500. What is the meaning of this? Means 8085 microprocessor can access 2 to the power 16 memory location, which is equal to 64 KB, because 8085 microprocessor have 16-bit address lines. Okay, now what will be the first memory location? If we have 16-bit memory address, now what will be our starting address, first address? It will be 4 times 0 h, and this h represents the hexadecimal number, means 0000 h is the hexadecimal number, and this is the starting address of any memory location which is specified by, yeah, which can be accessed by 8085 microprocessor. Now what will be the ending address of for this memory location? 16 times 1 means 4 times fh, because 4 times 1 is represented by f in hexadecimal numbers. That's why ending address for the memory location which can be addressed by 8085 microprocessor will be 4 times fh, from 0000h to ffffh. We can take any memory location. In this case, we have taken 2500h memory location, means 2500h is the memory location in this instruction. Now the contents of this memory location, that is 2500, it may be any 8-bit data from 00 to ffh, means in 8085 microprocessor we have data bus or data lines from of 8-bit, means from 00 to ffh. So what will be the output of this instruction? Means with the help of this LDA, load accumulator directly by the contents of memory location 2500h. Means what will be the contents? It may be anything. It may be 04, it may be 05, it may be anything which we have to use in our program. Okay, it may be anything, but here what we are going to be focused here, direct addressing mode, means in this instruction we are going to point up directly a memory location, right? In front of this instruction we have a address, that is 2500h, means uh, the address is directly specified within the instruction. Okay, LDA is the operation, 2500 is address of source, accumulator is the destination, means the contents of this memory location will move to the accumulator, and data, finally data will move with the help of this instruction from memory location 2500h to accumulator. Now LDA is a 3-byte instruction. How? In 8085 microprocessor, maximum size of any instruction is 3-byte only, and the example in front of you, that is LDA 2500h, means 1 byte, or our first byte for opcode, or that is LDA. It may be anything. It is previously defined by Intel company. Okay, for example, if this one is XX, okay, now this is our first byte, and what will be the second byte in this case? It will be 00, okay, and what will be the third byte? That is 25. Okay, so LDA is our 3-byte instruction. Now we can take another examples also, like STA. If we relate LDA and STA, now STA does just opposite operation of LDA. With the help of this thing, we can learn also in our mind how to learn two instruction in the same time. Means STA will store the contents of any memory contents of accumulator at given memory location. And this will also be the example for the direct addressing modes. In STA instruction also we have address in front of them, but it will do just opposite work of LDA. Means with the help of STA we will move the content from memory to microprocessor to memory. Means the content of accumulator will move into the memory location. Okay, now next one is register addressing mode. In register addressing mode, the data to be operated is available inside the register operand. Therefore, the operation is performed within various registers of microprocessor. Now, in 8085 microprocessor, we have various registers, as this is a 8-bit register, and we have some general purpose registers like B, C, register B, register C, register D, register E, register H, and N. HN register pair is also used as memory pointer also. Okay, now in register addressing mode, the operand is generally in general purpose register or in accumulator also. These all general purpose registers and accumulator are of 8-bit only, as 8085 microprocessor is a 8-bit microprocessor. That's why our these general purpose registers and accumulator are of 8-bit only. Okay, now here is an instruction, that is MOV A, B. This is the example for register addressing mode. In this case, MOV is the opcode for this instruction, and A, B, this is the operand for MOV A, B instruction. Now, what will be the output by this? Yeah, what will be the output of this instruction? This instruction will move the contents of register B comma B, it doesn't contain any 8-bit data or any 16-bit data. That's why MOV A, B, it have only one opcode or hexadecimal code only. That's why MOV A, B is a 1-byte instruction. Means it doesn't have any 8-bit data or 16-bit data within itself. Okay, this is register addressing mode. Now next one, okay, register indirect addressing mode. Third one है register indirect addressing mode. In register indirect addressing mode, the data to be operated is available inside memory location, and the memory location is indirectly specified by register pair. Okay, in this mode, indirectly address, which is specified by a term, that is M, and this M is represented some memory location. M stands for memory. But which memory location? Means in this instruction, we indirectly addressing some data. which is in any memory location which is represented by M here. Okay, now what is M? M is nothing but M is the memory location which is specified by the HL pair. Okay, means for example, if we have contained 1 2 3 4 in register H L pair, means in H we have 1 2 and in L we have 3 4, means in register pair we have 1 2 3 4. If the HL pair contains 1 2 3 4, means if we are using M, this is a memory location, means HL pair pointed up a memory location that is 1 2 3 4. Now what is the data, what is the contents of this memory location? It may be anything from 00 to FFH. For example, this content in 05, this 05 will move into accumulator. Okay, now with the help of this instruction MOV A comma M, what will be the output, what will be the outcome? This instruction that the content of memory location which is specified by the HL register pair will move into accumulator. Okay, and this instruction can be anything like MOV B comma M, M comma A, C comma M, means any general purpose register or accumulator, and M memory location. It can be like MOV M comma B. With the help of this instruction, the contents of register B will move into the memory location which is specified by the HL register pair. And this instruction is also 1 byte instruction, because MOV A comma M instruction is also only have there any hexadecimal code, that is single code, nothing 8-bit data or nothing 16-bit data in front of this instruction. MOV is opcode and operand is A comma M. No any 8-bit data and 16-bit data is specified by in this instruction. That's why this is 1 byte instruction. Okay, and now next one is fourth one, that is immediate addressing mode. In immediate addressing mode, the source operand is always a data. Means if we take an example of MVI A comma 05H, in immediate addressing mode, this operand is always a 8-bit data only, or 16-bit. It may be 16-bit also. Okay, in this case we have taken 8-bit data, MVI A comma 05H. And what will be the output of this instruction? This instruction, what will do? This 05 means any number in hexadecimal number from 00 to FFH. We can move immediately. What is the full form of MVI? MVI. Move immediately 8-bit data into accumulator. Move immediately 05H. H stands for hexadecimal number, 05H into accumulator. After execution of this instruction, the contents of accumulator will be 05. Means with the help of this instruction, we can immediately move any data in general purpose registers or accumulator. For example, we can take another examples also. MVI B comma 04H, MVI C comma 06H, and MVI A comma 05H is a 2-byte instruction. Now, how this is a 2-byte instruction? First of all, MVI A comma 05H. In this case, MVI A, it have some hexadecimal number, hexadecimal code for this instruction. It will be the first byte of this instruction. Means opcode for MVI instruction will be the first byte, and second byte in this case will be 05H, and hence when memory microprocessor will read this instruction from memory, so how the first machine cycle will be opcode fetch machine cycle, that is M1, and next machine cycle, second machine cycle will be memory read machine cycle. Means microprocessor will read the 05H from memory to microprocessor in accumulator. In which register? Accumulator. Okay. Now after the execution of this instruction, accumulator will contain 05H. Now next one and last one. Last one is fifth, that is implicit addressing mode. In implicit addressing mode, the operand is hidden in the data to be operated, is available in the instruction itself. Means in this addressing mode, we don't have any 16-bit number, 8-bit number, or any register in front of instruction. We have various types of instruction in our 8085 microprocessor instruction set. Those don't have any register or any 8-bit data in front of them. Okay. If here we have taken an example of CMA instruction. CMA instruction is used for the complement the contents of accumulator. Means after execution of this instruction, the content of accumulator will be complemented. Means if we have 8 times 1 in accumulator, and after that we use this instruction, that is CMA. Now with the help of this instruction, contents of accumulator will be for 8 times 0. Okay, means with the help of this instruction, what we have done, the contents 1 will be converted into 0. Means it will be complemented, the contents of accumulator. So then CMA instruction, what will do, it is a 1 byte instruction, and it will complement the contents of accumulator. In this case, we accumulator is the source and accumulator is also the destination. Both operation will be performed within the accumulator only. And CM is also a 1 byte instruction, because CMA only have their opcode, hexadecimal number, which is already specified by the 80 Intel company for 8085 microprocessor. So this is the addressing modes of 8085 microprocessor, and we have 5 addressing modes. Once again I repeat, all addressing modes: direct addressing mode, register addressing mode, register indirect addressing mode, immediate addressing mode, and implicit addressing mode. And what is the addressing modes for 8085 microprocessor? The way of specifying data to be operated by an instruction is called addressing mode. And in 8085 we have 5 addressing modes, which we have discussed in this video. Thank you.